Have you ever been sitting on a plane, looked out the window at that giant engine on the wing, and just wondered, how on earth does that thing actually work? I mean, it seems like some kind of magic, right? Well, today, we're going to pull back the curtain and break it all down. So let's fire it up and see what makes these incredible machines fly.
All right, here's our flight plan for this explainer. First up, we'll meet the workhorse of modern aviation, the turbofan engine. Then, we're diving deep inside its core to understand the simple but powerful squeeze, bang, and blow process. After that, we'll uncover the really clever secret of something called bypass air. And to top it all off, we'll look at the raw, awesome power of fighter jet afterburners.
So that engine you see hanging on the wing of pretty much any airliner, that's called a turbofan. And yeah, it looks incredibly complex from the outside, but the basic idea behind it is actually surprisingly simple.
Okay, so let's forget all the complicated bits and pieces for just a second. At its heart, you can really just think of a turbofan as a super high-tech propeller, but it's stuck inside a tube or a duct. That's the fan part of the name. But what's actually making that fan spin? Well, that's where the gas generator comes in. And this gas generator, it's literally the heart of the whole operation. You can almost think of it as a tiny, super powerful engine inside the main engine. And it's got one crucial job. We call it the core. This is where the magic really happens, where all the power is born.
All right, so let's crack this thing open and take a look inside the core. This is the part of the engine that sucks in regular air and basically turns it into a jet of insanely hot, high-pressure gas.
So the air has to travel through the core in a very specific order, hitting three key sections. First, it gets slammed into the compressor. That's where it gets squeezed. From there, it moves into the combustor. You can probably guess what happens there. It gets mixed with fuel and lit on fire. And finally, that fiery blast of gas is used to power the turbine.
So look, the main takeaway here is that this whole setup, the compressors, the combustors, all of it, it has just one job: to create an incredibly powerful jet of gas. And why does it need that jet? To spin the turbine that's sitting at the very back of the core.
You know this whole complicated process inside the core? You can actually boil it down to three really simple words. It's this beautiful, efficient cycle, and it's the secret sauce behind pretty much every jet engine out there.
All right, here they are: squeeze, bang, and blow. First, the engine squeezes the air, just packing those molecules together super tight. Then comes the bang, lighting up that fuel-air mix. And finally, blow, where that incredible explosive force is channeled out the back to do some real work. So let's break down how each of those steps actually works.
Okay, the squeeze. This all happens in the compressor, which is actually made up of a bunch of stages. Now, each stage is a pair. First, you've got these spinning blades called rotors. Easy to remember because they rotate, and their job is to speed up the air and throw it backwards. But right after them, you have these stationary vanes called stators, because they're static, they don't move. They grab that fast-moving air and slow it way down. And that sudden deceleration, that's what jacks up the pressure. They work as a team, one stage after another, building more and more pressure.
And we're talking about an insane amount of compression here. A big modern turbofan might have something like 14 different stages of compression. We're talking maybe 4 low-pressure stages and then 10 high-pressure ones, each one just piling on more pressure until that air is incredibly dense.
All right, next up, the bang. So that super pressurized air flows into the combustor, which is kind of shaped like a donut. And inside, you have these fuel injectors that are spraying a super fine mist of jet fuel into the air, creating this perfect, highly explosive mixture.
So how does it all ignite? Well, you've got a couple of igniter plugs that give it the initial spark. Honestly, it's not all that different from the spark plugs you'd find in a car engine. But here's the cool part. Once that fire starts, it just keeps going. It's a continuous, self-sustaining burn for as long as you're feeding it fuel and air.
And that brings us to the final step: blow. All that super hot, high-pressure gas from that continuous explosion has to escape somewhere, right? So it blasts out of the combustor and just slams into the turbine section, spinning its blades at insane speeds. Just picture a really, really powerful gust of wind hitting a pinwheel.
Okay, so the turbine is spinning like crazy. What does it do with all that energy? Now, you might think its job is to push the plane forward, but nope, that's not its main gig. About a quarter of its power gets sent right back to the front to run the compressor. It's powering its own process. But the other 75%, the huge majority of the power, is used to spin that massive fan at the very front of the engine. And that fan, well, that's the real secret to how modern jets work.
So we've just spent all this time talking about the engine's core, right? But here's the ironic part.
The real key to making a modern airliner so efficient and quiet is actually the air that never even goes into the core.
Yeah, this is what we call bypass air. That giant fan at the front, the one being spun by the turbine, it's actually pushing most of the air around the core, not through it. It's this big, slower-moving column of air that actually generates most of the engine's thrust. The core, in a way, is just a power plant for the fan. And this whole concept of bypass ratio, how much air goes around versus through the core, it creates two totally different types of engines for two totally different jobs. On one hand, you've got the high bypass engines on commercial airliners. Most of the air bypasses the core, which makes them huge, quiet, and super fuel efficient, perfect for cruising for hours. On the other hand, you have low bypass engines, which you'll find on fighter jets. A lot more air goes straight through the core. This makes them smaller and built for pure raw power and supersonic speed, but man, are they loud, and they just drink fuel.
You know, another huge win for that high bypass design is how quiet it makes the engine. All that slower-moving bypass air acts like a giant, invisible blanket of sound insulation. It wraps around the super hot, screamingly fast exhaust coming out of the core. This is a huge reason why sitting in a modern airplane is so much quieter than in the jets from, say, the 60s or 70s.
Okay, let's switch gears and go back to those loud, thirsty, low-bypass engines on fighter jets. They need insane on-demand power, and to get it, they have a pretty awesome trick up their sleeve.
So let's say a pilot needs a massive, sudden kick of power, maybe for a super steep takeoff or in the middle of a dogfight. How do they get it? The answer is a system that is as brutally simple as it is powerful: the afterburner.
So here's the deal with an afterburner. After all that hot gas has already done its job, gone through the core and spun the turbine, it gets dumped into the exhaust pipe. When the pilot hits the afterburner, a bunch of fuel injectors just spray raw jet fuel directly into that stream of hot exhaust. Now there's still unburned oxygen in that exhaust, so it instantly ignites the new fuel, creating a second massive explosion right in the tailpipe. It's just this huge, incredible kick of extra thrust.
But as you can probably guess, this incredible power comes with some serious trade-offs. First, afterburners are ridiculously inefficient with fuel. I mean, they just guzzle it. That's why pilots only use them in short, controlled bursts. And to handle that sudden massive increase in pressure, the engine needs a special piece of hardware at the very back, a variable exhaust nozzle that can open up wide to let out that massive plume of fire. So from a simple fan inside a tube to the controlled fury of an afterburner, the jet engine is just an absolute marvel of engineering, isn't it? It's a technology that has completely reshaped our world, and it really makes you think, with this kind of power already figured out, what's the next big leap in engine technology even going to look like?